Ahmad Azlan bin Abdul Aziz. The title is Toward Robust in Car Connectivity, Simulative Insights into the Behavior of Single Patch and 2x2 Array Antennas for 2.4 gig Wi-Fi application. Okay, I share the video first from Dr.
Okay.
Ahmad Azlan.
Okay.
This one, the video from Dr.
Yeah.
Okay. I play first, huh?
Assalamualaikum. Hi, and a very good day for everyone. Today, I would like to share some of our findings that related towards the research on the vehicular by incorporating with antennas for 2.4 gigahertz Wi-Fi application. So basically, our title is on towards robust in-car connectivity, simulative insight into the behavior of single patch and 2x2 array antenna for 2.4 gigahertz Wi-Fi application. Zero. So this basically we are uh, proposing to enhance the signal of or the connectivity of the car from the omnidirectional to directional by using this IEEE 802.11a Wi-Fi standards. On our next slide, we are focusing on the gaps or the problem statement for our research paper, and also we will introduce and elaborate on the backgrounds of our research. So what are the problem and also the gap for our research? Basically, the placement of antenna is placed in the middles of the car, whereby all the audio system and also the what we call it connectivity place. So basically this is the place for omnidirectional. And then what are these antennas do? The antenna will radiate in the form of omnidirectional that will cover 360 degrees of a radiation pattern. And what are the problem of this omnidirectional previously or currently being used? It only covered in in the form of 360 degrees, and it might give what we call that blind spot signal that will give some weak signal on this place or this spot. So it will produce uneven signal right up from top of the car until at the back of the car. So it will give some inconsistent signal. So this is we try to promote some of the solution that it will enhance the signal instead of only cover in front of the signal, whereby on this boot of the car will not be necessary. We want to extend the signal by using omnidirectional to directional signal that will hunt the signal on the backward, rather than covered in front of the boot of the car, whereby there's no user. We enhance the signal, extend the signal by using the directional, push the signal from the middle of the car until the back end of the car. So basically these are the problem statement whereby the signal is not even from in front of the car until back of the car. So what is actually the introduction and background for our research? Emerge of vehicular connectivity. The second one, we will increase the need of robust connectivity. The third one, we will focus on current challenges in vehicular connectivity. And the last one, we will explain why the antenna configuration matters. So for the emerged connectivity, in today's technology area, vehicles have very increasingly integrated with advanced system. Gone are the days where vehicles slowly relied on basic connectivity for navigation. So now they are interfaced with range of sophisticated onboard system, transforming them into highly intelligent machine. This integration has been primarily driven by the rise of the Internet of Things in vehicular technology. And the second one, with this evolution of vehicle, there are a heightened demand of consistent and high-speed connectivity. It is not just about streaming your favorite song or using navigation anymore. Modern vehicles require connectivity for essential functions such as safety alerts, real-time navigation adjustment, over-the-air system updates, and even interaction with smart city. Or maybe another, or in a tunnel, your vehicle lost its signal. This inconsistent signal can affect the vehicle performance and the user experience, such as connectivity issues are common due to the complex terrain and also the dense built urban landscape. And the last one, why antenna configuration matters. This brings us into the importance of antenna configuration. Antenna play a pivotal role in ensuring the vehicle remain connected in respective of the environment. They captures and relay signal acting as the vehicle communication lifeline. Therefore, re-evaluating and innovation antenna design can significantly enhance Wi-Fi vehicular connectivity, making journeys smoother and more informed. Okay, next we have ventures into the research objective and the scope of our research. What are the purpose of the research? As we transition into the era of dominated by smart vehicle and intelligent transport system, one element stand out paramount: reliable connectivity. It's very important on the connectivity. Ensuring a seamless connection is crucial, not just for luxury, but for the functional of contemporary vehicle. My primary research aim is to be amplify the vehicular Wi-Fi strength and also the reliability. So the next one is comparative. We are what comparative what approach that we are using? We are using the comparative approach. To address this, I adopted a comparative approach. Instead of merely focusing on enhancing the antenna's design, I explore two distinct configurations. One, the distinct single patch antenna, and more advanced 2x2 antenna. One is a single patch and one is 2x2 array. This comparison isn't merely academic. The real-world application of our finding could influence the very backbones of vehicular connectivity. The second one, antenna role in connectivity. Think of the antenna as the ear of your vehicle. It listens and communicates with the surrounding environment, ensuring your car stay connected and informed. A well-designed antenna doesn't just improve signal strength, it ensures consistency, reduce those frustrating moments, and lost connectivity or buffering cycle. So basically, the whole idea is changing from omnidirectional that currently being implemented, proposed on the single patch antenna. This is our first contribution, and also the second contribution is 2x2 array, enhancing the single patch. So the main objective, provide more gain in one direction with a scope on simulation and patch. Why patch antenna in this scope? Because due to the low profile. So now we are moving into the next slide that ventures into antenna design methodology. So these are our first design that focus on the quarter wave, single patch quarter wave feeding technique, and then we enhance the design to improve the gain by using 2x2 array. So what are the equation that we use? This is a standard resonant frequency whereby C is the speed of light, 3 times 10 power of 8 meter per second. FR is stand for resonant frequency. In this case, we are using 2.4 gigahertz standard Wi-Fi IEEE 802.11 A frequency standard. And then we have ER, relative permittivity of the substrate, whereby this is 3 point something. ER is 3.8 something that we are using for the material. And these are the quarter wave. Quarter mean 1/4. So from this equation, we transform it into this quarter wave equation, and we use it to get this what we call that numbers. So how we get these numbers is based on this equation, equation 2. Then we are moving into the 2 by 2 array, whereby we introduce this power divider. And the problem with the power divider is it will disturb the impedance. So that's why we are using this equation 3 to improve the impedance, to make sure that we arrange the patch of an antenna, the first patch, the second patch, third patch, and also the fourth patch in the optimum performance, so that make sure that the output is follow as our expected. So for the result and analysis for single patch, basically we are using the epsilon r. This is epsilon r, or permittivity of the material is 3.05, and also the loss tangent is 0.0082, whereby this material is UPB 7030, is the biocomposite material that have the dielectric constants of 3.05 and also the loss tangent 0.0082. This value is very important when you design using the CST software. You have to provide the material properties like dielectric constant and also the loss tangent. Okay, so we are moving into the radiation pattern. So as we expected, we transforming on the omnidirectional that have typical 300 degrees of a radiation pattern into more directive design. So we are enhancing the gain currently, and we enhance normally omnidirectional will provide on the 2 dB gain, more likely to be almost 2 dB gain. Then we are enhancing our main loop to be 2.8. So we are improving 0.8 gains by introducing the single patch antenna. And these are the S11 written loss for the 2.42 gigahertz as the center frequency. Even though we are expecting 2.45, 2.45 is somewhere around here, still in the what we call that acceptable frequency, whereby as our expected frequency is what we call that the expected frequency here is expecting to operate in 2.45 gigahertz, and we get the gain as 2.83, and efficiency 51%, more than 50% is acceptable, directivity 5.8, front to back loop is 10 dB, 88 degrees, 2.42 center frequency, the operating bandwidth 2.39 until 2.46, which means that our expected frequency is under the acceptable operating frequency, which indicate that this frequency can be, our antenna can operate in this 2.45 gigahertz. So the S parameter magnitude is minus 40.6 dB, and the BSR-WR voltage standing wave ratio is 1.02. Very low reflective antenna, and is indicate that in the good condition as our expected. Next, we are moving into 2 by 2 array, whereby we have more advanced gain 5.8. It enhanced from 2.85 to the 5.8, and with the impedance 49.076 and 49 something, and also minus 1.7. Minus in this condition indicate that our antenna influenced by the capacitive output. So for the S11 still manageable, still in good condition, 2.42 as the center frequency, and 2.5 in the range of expected operating frequency by focusing on this simulation S11 written loss graph. And gain versus frequency, again it shows that the peak of the gain shows in the 2.42 with the gain of 5.8, and it will cover the whole expected frequency that we want to cover, and stable of the surface current operating, and these are the output when comparable overall simulation 2x2 array when compared into the single patch. These are the 5.8, the percent of deviation 51, which means that this all the improvement compared to the single patch. So this is the final conclusion for our design is 2x2 array antenna outperform single patch antenna. And as the conclusion, we have four conclusions. One is significant enhancement, overcoming efficiency hurdles, balanced design and performance, and number four, paving the way. So these are the conclusion as our expected. And the implication and future works, we expected that profound impact on vehicular connectivity, overcoming challenges. As the future work, our research has opened door to myriad possibility and the next step into the ventures of array antennas for vehicular. And as the big picture, as we stand in the customer of vehicular revolution, we enhance by the IoT and AI, ensuring robust vehicular connectivity become indispensable. This research doesn't signify an evolution in antenna design, but paint a promising picture for the future of vehicular communication system. By there, I open for Q&A and thank you very much.
Okay, thank you, Dr. Ahmad Azlan, for interesting topics. Okay, now we open for any question to Dr. Ahmad Azlan. Anyone can ask. Okay, if don't have any question, now we're moving for second presenter. Okay, please welcome Dr. Sheikh Muhammad Sultan from UTB. For title is a survey on public travel behavior, vehicle usage, and consumer perception of electric vehicle in Brunei Darussalam. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good morning to all. Myself, Dr. Sheikh Muhammad Sultan from University Technology Brunei. I'm going to give a presentation on the topic a survey on public travel behavior, vehicle usage, and consumer perception of electric vehicle in Brunei Darussalam. Let's begin with an introduction. Emissions from the transportation sector is a significant contributor for the climate change, which leads to global warming and making it a critical issue in addressing global environmental challenges. In recent years, electrified transportation has emerged as a promising solution to mitigate the effect of these emissions and to work towards limiting the temperature rise to a specified target set for 2050. Though electric vehicles are growing or the market is emerging and people are thinking about buying the electric vehicles, still the consumer perceptions and knowledge about electric vehicle really adapt the adoption rates. So a public opinion survey conducted in Brunei Darussalam mentioned for understanding the vehicle usage pattern, travel behavior, and the willingness of individuals to transition to the electric vehicles. Electric vehicles become a topic of talk in recent times. However, electric vehicles are not new to the market. The first wave of electric vehicles hit the market in 1800s. A full electric driven garage was invented by Scotsman Robert Anderson between 1832 and 1839. That's what you are seeing on right top. In late 1800s, electric vehicles hit the US auto industry and started gaining popularity. The first commercial electric car, Electrobat, was designed and built by Henry G. Morris and Petroji in 1894. However, over the time, due to various reasons and the cheap availability of fuel and also the low cost of internal combustion engine based vehicles, it was swiped out from the market. Nearly after 100 years, in late 1990s, the second wave of electric vehicles have arrived. What you are seeing at the right top is the Toyota's electric car, which was introduced sometimes late in 1990s. However, due to the cost of power electronic converters and batteries and the other technical and economic factors, it doesn't really succeed. Again, nearly after 2 decades or 120 years after its introduction, the electric vehicles have become famous and gave an unmistakable comeback. In 2010, GM released Chevy Volt, a first commercially available plug-in hybrid electric car. Electric cars offer several advantages. Electric cars are absolutely emission-free. The operational cost and maintenance cost of the vehicle are less. The efficiency of the vehicle is more when compared to internal combustion engine vehicles, and the maintenance is comparatively less due to the lesser parts when compared to that of the internal combustion engine vehicles. And in recent times, whenever we think about electric car or whenever somebody is talking about electric car, the first car which comes in our mind is Tesla, and we must thank Tesla for bringing up electric car famous among the public across the world. This figure shows the well-to-wheel efficiency of internal combustion engine car and battery electric vehicle. If you have a look at it, in the case of internal combustion engine vehicle, the crude oil is going to refinery, then it is going to filling station where the efficiency is considered to be 83%, and the efficiency of IC engine vehicle is only 13%, wherein the efficiency of battery electric vehicle, though it come across different stages of generation and transmission of power and battery charging, the efficiency is still high. This figure shows the tank to wheel efficiency of electric car, where battery electric vehicle has 72% of efficiency from tank to wheel, where the main source is electricity. In the case of fuel cell electric vehicle, the source is hydrogen and the efficiency at wheels is 40%, while in IC engine vehicle the efficiency at wheels are only 16%, which is much lower than that of battery electric vehicle. As I stated before, though there are several advantages for electric vehicles, there are still challenges in adopting electric vehicle. One of the main challenges is the cost of the vehicle. The cost of the vehicle is more or less double than that of the IC engine vehicle for a specification of the car. And the lack of charging facilities and charging infrastructure is another biggest challenge, which led people to not think of electric vehicle. Whenever you approach any public and ask them about buying a car, they always ask you a question: where are the charging stations? Range anxiety is another biggest challenge, because due to the lack of charging facilities and charging infrastructure, people are afraid what if the car stops because the battery drain out, And as I stated, range anxiety is another biggest challenge. Charging time of the car, when you go and fill fuel in your car, it will take hardly 10 minutes to finish up the job and continue your journey. Wherein for the electric cars, charging time is a significant factor, because on an average in a normal charging case, it will take 8 to 12 hours to charge your car fully. Reliability and safety of the vehicle. Again, public are still not ready to accept the fact that the electric cars are reliable and safe. So we have conducted a survey in order to understand what public thinks of and what are their user behavior in current scenario while using the IC engine cars, and also what is their thought process about electric vehicle. The questions and the responses collected from the public are posted here. We have received more than 100 responses. To be very specific, we received 104 responses, and from these responses you can see from question number 1, when you have a look at this one here, the first question was how many cars are there in your house, because in Brunei the culture is different and you can expect a minimum of 2 cars in any home. So if you have a look at it, only 7.7% of the public are having 1 car at their home. And have a look at this one. So there are 5 cars in 12.5% of the community, 20.2% of the community has 4 cars, 17.3 has 3 cars minimum. So when you have a look at this response, 1 car is the least possibility in Brunei. The average distance between the workplace and their home was the second question, and 37.5% are working in a distance of 11 to 20 kilometer. 19.2% travel between 19.2% travel less than 10 kilometer for their work, and 20.2% travel 21 to 30 kilometer for their work. But there is a good amount of people, they are traveling more than 60 kilometer. If you have a look at this one, 8.7% responded that they are traveling more than 60 kilometer, or the distance between their workplace and the home is more than 60 kilometer. Other questions are how many kilometers you drive in a day. Bruneians generally drive a lot, and 34.6% drive more than 200 kilometer in a day, where 22.1% drive 51 to 75 kilometers. And again, I am sorry about that. 34.6% of people drive between 25 to 50 kilometer, and 9.6% drive 76 to 100 kilometer in a day. The amount spent for fuel in a month, the response is here. 32.7% spend around $40 on an average per month for fuel. 16.3% spend $76 to $100 per month for fuel, and 20.2% spend more than $100 per month. This is a very significant data. So they spend more money for fuel, that you can see from this result. 1/5 of the respondents are spending more than $100 for fuel. Then we ask a question whether they would like to buy electric cars in future. 40+% said yes, 24% said they will not buy, and 35.6% said they may or may not buy an electric car in future. So what is the reason for not opting EVs? The factors we have given are cost of the vehicle, charging time, charging station, and range anxiety, environmental thing, expensive replacement cost of the battery, electric motor price, then cannot drive overseas because of the range. These are all the responses what they have provided actually. So this give you a mixed understanding about electric vehicles. So cost of the vehicle 75%, 27 respondents said that cost of the vehicle is high. Yeah, of course it is true. Charging time, again that is a right factor. Charging station is another right factor. Range anxiety, some people have range anxiety, and some people think that it also destroy the environment. Likewise, so this is another factor to be accepted, that replacement cost of the battery is high. But this is about the understanding. How do they think that electric motor or electric are more expensive than fuel? It comes from the thought process that electricity will cost more when they are connecting the car for charging from the utility system, because it will double up. We are using block based electricity price there. They are afraid of this one. Then the preferred location, the other question asked was what is your preferred location for charging stations, and 59% prefer to charge their car from fuel stations. 64 have a very good understanding and they prefer shopping mall. Again, another 58% think that supermarkets are good place to charge your car, and the understanding again is correct here that 67% prefer to charge their vehicle from their office parking. Of course, people prefer to charge their car from home also. So with these things, I would like to conclude the presentation with the following insights: that addressing climate change requires a concentrated effort to reduce emissions from the transportation sector, and electrified transportation is a key solution in this endeavor. Electric vehicles offer a range of benefits, from reduced emissions and operational costs to improve the energy efficiency. However, challenges related to affordability, charging infrastructure, and consumer perception must be addressed to accelerate the transition to electric vehicle, because though the market is emerging, still we have a lot more to do in order to penetrate the electric vehicles into the market. Public opinion surveys like the one we conducted in Brunei Darussalam will definitely provide valuable insights into these challenges and can inform policies and initiatives that aimed at achieving a sustainable, low carbon transportation future by 2050. Thank you for your listening to the presentation. These are some of the references. Thank you again.
Okay, thank you, Dr. Sheikh Muhammad Sultan. I open the floor for the Q&A. If there are any questions? Yes.
I can ask the question.
You can ask the question. Dr. Sheikh Muhammad, are you there?
Yes, please proceed.
I have a question
From
one of the students from Polytechnics.
Okay.
Please introduce your name. Can we speak Bahasa Melayu?
No.
Dr. Sheikh? Okay, boleh ha, Dr. Sheikh.
Thank you. For that,
Translate the question, yeah.
Okay, you can ask the question.
my name is Amin Skandar from Bachelor Mechanical Engineering. May I ask you for the average fuel consumptions and average distance from home and workplace, which is how doctor get the reference for the average stuff,
Distance. The length.
dia apa jarak tu ada average fuel consumption and then apa average people getting home from home to workplace, just like the slide.
Actually, we here in Brunei Darussalam, their driving pattern is a bit different when compared to other places, because here people completely rely on their car for all kind of transportation, because there are you cannot find two-wheelers. Two-wheelers are used only by the hobby people, and also the public transportation is very limited and it is not used by people. So you know how much is the mileage of any car, basically, right? And from this average mileage of your car and also the number of kilometers you are driving, you know, like I shown one slide where I mentioned that people are using more than $100 for fueling up their car. The actual price of the fuel, I mean petrol in Brunei is only 50 cents, which
50
means that
cents.
50 cents.
Sorry.
So you listen, when they are paying more than $100, let's say that they are paying $100. So in a month, they are filling up 200 liters of petrol in their car, right?
Okay, all right.
Imagine how many kilometers they are driving in a month.
How many kilometers?
Let us say that the mileage of the car is only 10 kilometer. In the worst case, let us say the car give you only 10 kilometer mileage, which means you are traveling on an average of 2000 kilometer a month, right?
Yes.
The average distance of Bruneians driving is 50 to 100 kilometer from my understanding. And some people are driving hardly, some people are actually the problem is it's not a problem. So the distance from we call it Kuala Belait, which is near to Miri, Kuala Belait to Brunei city. Some people work in city, and the distance is 100 kilometer from Kuala Belait to Brunei, and they drive every day. Some
Okay.
of them.
Mm.
Then from that you can understand how much they are spending and what is the mileage they are covering. This is the data. So from here only we are trying to, and what we feel is that the from one end to another end, it is not like Malaysia, right? From one end
Yes.
to another end, Brunei you can cover in 200 kilometer.
200 kilometers, yes,
So,
small.
so there are more possibilities and feasibility to adopt electric vehicle. For example, the Kia Nero EV5 has a range of 395 kilometer. So you can drive to Kuala Belait and come back in a day, and you can put your car for charging at night, and it will be ready for drive next day with a reserve of a minimum 150 kilometer. That is the thing. So this is where we got the average mileage at the other day. Interesting, right?
So any other questions?
No, thank you.
Thank you. There is more questions from the student, Dr. Sheikh. Okay. Introduce your name and which department?
Hello, my name is Muhammad Azim bin Shahizam. I'm studying in Bachelor in Mechanical Engineering.
Okay.
And my question is, is this technology of autonomous vehicle or electric vehicle does have like battery compartment, right?
Yeah.
May I know how the production of the battery cell, because I want to know, is it whether eco green or not?
How to make the batteries?
Yes.
Okay.
Is it the mass production or not?
It is always a mass production. Actually, if you have a look at the battery cells, I don't know. I think that I don't know whether I mentioned it somewhere in between. If like the batteries in electric cars are not like the conventional batteries we use for the lighting purpose. You know how a battery looks like in a car, right? The conventional battery. In IC engine car, every car we have a battery, right? A 12-volt battery, which is of a square type box, isn't it?
Yes.
But that is the lead acid battery we mostly use. But in the case of electric car batteries, those batteries looks like the battery cell which we use in our clock, and it is produced in mass. They are packed as a stack like the hard disk, old type hard disk in a box, by connecting them 10, 20 cells in a pack, and then they are all connected together in such a way, and it is kept in a platform of the car. So if you think that in battery electric vehicle, the batteries are kept in the bonnet or in the boot, it is not. The battery stacks are laid on the platform of the car. and it is mass produced mainly. But there is another concern because there is a lot of mining happening in South Africa to produce the battery, which is again spoiling the environment. I'm a bit worried about that also. Yeah.
Thank you for
Explaining.
thank you for explaining to me.
Okay. Yeah. Any other questions? Yeah, the one more student interested. The last question, Dr. Sheikh, from the student also.
Okay, doctor, we meet again. Okay, I would like to ask a question about the EV car because actually I'm interested for buying an EV car for my daily use. But what I concern is about the charging stations because there are very lack of charging station in Malaysia.
Yes.
I think and as you see the distance travel Malaysia is very far. So it by how to say like I'm nervous about the charging rate and charging range for the batteries. So how doctor will like to persuade the government for implementing the charging station in cover more coverage in Malaysia?
From my understanding, I recently attended a dialogue session with the head of Sarawak Energy, which was in the energy transition. And Sarawak Energy is taking quite a lot of initiatives to implement charging station across the state in Sarawak, and they are planning to expand it to Malaysia also. Every time I receive this question, as long as we don't have a charging station, that is what I stated as a range anxiety. As long as there are no charging stations, how we can go for an electric vehicle? Electric vehicle and charging station are always a chicken egg problem. What comes first? So when you need more charging stations and there must be more electric cars on the road, then only those investors will come forward to install the charging station, and also the public sector will show interest because charging station as a potential investment not only belongs to one particular stakeholder. It has a stakeholder of landowner, then the electricity, then the supplier of charging station, then the aggregator. There are several things to be taken care of. But however, as I mentioned, to answer straightly to your question, Malaysia is taking quite a lot of initiatives to bring charging stations, and you will find plenty of charging stations in another few years for sure.
And how about the charging? Because now, as I know, the charging time is quite long for
Charging time is high, yeah, because charging times takes for the level 2 charging station, it takes 6 to 8 hours. But there are more rapid charging stations coming into the market. The recent one is charging the vehicle in 20 minutes, and I heard that there is a 320 kilowatt DC fast charger which will charge your car in 10 minutes. Technologies are coming, but it will take a bit more time. You need to compare this with the since you are from mechanical or automobile engineering. If you have a look at the history, we have more than 200 years of history for internal combustion engine vehicle, and electric cars are in the market hardly from 2000, which means it is only 23 years now. Right, so we have a long way to go.
So I hope one day the charging speed will as fast as how
Not
we
only
fill our tank.
the technology already exists, and we will have it soon. But in another few years, you will find the rapid charger across the state, inshallah.
Yes, because as my family concerned, the charging speed is quite taking a long time. Why not can we achieve as rapid as how we refill a tank?
It is coming. It is coming. That is what I said. It is already available in the market, and it is all about policies and infrastructure plus investment to deploy the charging stations. They are more coming in.
Okay, thank you, Doctor, for your explanation.
All right.
Thank you,
Thank you,
Sultan.
Dr. Sheikh. Okay, so now we go to the last presenter, Dr. Vishnu Arjin from TKM College. Dr. Vishnu, are you there? Dr. Vishnu?
Hello, I'm audible.
Hello, yeah. Okay, thank you. That's all. We cannot share the video. Can you share? We leave to you the presentations. Can we make you as a presenter? What is it? Can
You can share the video.
Okay, can I
okay,
play?
you can. Uh, all right, you can share. I leave the floor to you.
1 minute.
Dr. Vishnu.
Yes, I'm searching for the video. Is that okay? Is it visible?
Visible. The floor to you now. Thank you.
Welcome. Good morning, everyone. My name is Vishnu Arjit. I'm a BTech student currently pursuing electronics engineering in College of Engineering, Care.
Sorry, Vishnu, we cannot hear the voice.
Hello.
Now we can hear.
What? Sorry, pardon. Am I audible? Hello.
Yes, yes, I can hear your voice.
Yes, yes, Vishnu, we can hear. Say it loudly, please.
Is this video? This video is all
Your
audible.
voice is too low. That is a problem. If you speak loudly, it will be okay.
I think it's the issue with the mic. I think. Is this video audible?
No, they said they are not able to play the video recording.
The one which I presented, the sharing, is that audible?
No, now you present it. It's okay.
Can
You
I
can play the video. If you can play the video, you play the video from there.
Okay. So I can.
Vishnu, you have the video, right?
Bad as I have the video, I'm sharing it.
You are sharing the video only now?
Sir, I didn't get it. What?
വിഷ്ണു വീഡിയോ അയച്ചു കൊടുത്തായിരുന്നോ?
അയച്ചു കൊടുത്തായിരുന്നു.
ആ വീഡിയോ ഇപ്പൊ കയ്യിലുണ്ടോ?
എന്റെ കയ്യിലുണ്ട്.
അത് പ്ലേ ഈ PPT പ്ലേ എന്ന് സ്റ്റോപ്പ് ചെയ്തിട്ട് ആ വീഡിയോ പ്ലേ.
ഞാൻ വീഡിയോ പ്ലേ ചെയ്യണം സാർ, കാണാൻ പറ്റുന്നില്ല.
കേട്ടില്ല.
ഞാൻ PPT വീഡിയോ പ്ലേ ചെയ്യുവാണ്, കാണാൻ പറ്റുന്നില്ല.
വീഡിയോ ഇപ്പൊ പ്ലേഡ് ആണോ വീഡിയോ ഓൾറെഡി?
അല്ല, ഓഡിയോ കേൾക്കുന്നില്ല.
അതിന്റെ ഓഡിയോ കേൾക്കത്തില്ല, വീഡിയോയുടെ ഓഡിയോ കേൾക്കത്തില്ല, അതാണ് വിഷയം. അതാണ് വിഷ്ണു PPT പ്ലേ ചെയ്തിട്ട് സംസാരിക്കാൻ പറ്റുമെന്നാണ് ചോദിച്ചത്.
ഓ, ഞാൻ ഇപ്പൊ പ്രസന്റ് ചെയ്യണോ?
ആ,
ഓക്കെ ഓക്കെ.
yeah, present it, okay? So moderator, sorry to override you. I just want to make him understand, okay? So I speak to him in his language.
Thank you, Dr. Shea. Thank you for the explanation. Really good. Thank you.
Yes, he was playing the video so that we couldn't hear the voice. I asked him to present now. Yeah.
Yes. Thank you.
Okay. Vishnu? Vishnu, unmute your mic. Okay.
Is it now visible and audible?
Yeah, this is visible now. Go ahead.
My name is Vishnu Arjit. I'm a BTech undergraduate currently pursuing in Electrical and Electronics Engineering in TKM College of Engineering. So today I'm going to give a comprehensive review on the thermal runaway in electric vehicle lithium-ion battery. So we know that in the rapidly growing electric vehicle sector marked by notable strides in the lithium-ion battery technology and the significance of ensuring the battery safety become more important. Despite the advancement in the electric vehicle industry, the ongoing occurrence of the fire accident underscores the persistent concern regarding the battery safety and poses a hindrance to the widespread of the adoption of EV. So the risk of thermal runaway in EVs is associated primarily with the lithium-ion batteries, which is the commonly used in electric vehicles. So the thermal runaway in electric vehicles arises from various factors, including overcharging and discharging of lithium-ion battery, and the physical damages to the battery, or due to the manufacturing defects, or exposed to the high temperature, etc. So the causes of thermal runaway. What is thermal runaway is of lithium-ion battery is the phenomenon of chain of exothermic reactions within the battery, which eventually leads to the explosion or the failure of the battery. So the battery manufacturing defects and battery abuse conditions like the mechanical abuse, electrical abuse, or the thermal abuse are the common causes of the explosion, which are actually caused by followed by the internal short circuit. Right. So the most instances of the electric vehicle fire result from the thermal runaway of the battery triggered by the internal short circuit. So therefore, to find out the internal short circuit in the battery and the early detection of the thermal runaway can eliminate the potential hazards or potential accidents due to the battery. So here we will discuss the online internal short circuit detection. So the manufacturing defect and overcharge issue are the most likely causes of the internal short circuit of the battery cell. For the identification of the battery internal short circuit, we can in online we can monitor the voltage parameters and temperature parameters. So here we in order to identify the battery internal short circuit, 3 different voltage signals are compared. That is the external short circuit, internal short circuit, and poor wiring short circuit. So in all these in these 3 signals, for the external short circuit occurs, the battery voltage would drop dramatically to nearly 0. That is, here we have the graph of how the external voltage circuit, its nature. That is, when we measure the voltage due to the external short circuit, its nature is always like this. It dramatically drops to 0 and may jump back and forth. And for the ISC, there would be a continuous voltage drop. That is, in the second picture, where we can see the internal short circuit, and the nature of that internal short circuit voltage drop is continuous and it drops to 0. And for the poor voltage signal wiring, is usually caused by a loose connection. As you can see for the showing device, its contact is in a loose connection, actually a floating point, because it is not because of that poor wiring connections. The voltage nature will be in this the third graph. As you can see, the one terminal voltage will go to up and other will go to down because it is in a floating state. So from these 3 voltages that we can measure from the battery, we will be able to find out, we will be able to uniquely find out the internal short circuit that happens to the battery. So therefore, the continuous drop is a unique feature of the battery internal short circuit. So this feature can be used to detect the internal short circuit online. So in the BMS, the battery cell voltage difference, that is delta Vmax, is continuously monitored. So where you can see the equation for the delta Vmax is Vmax minus Vmin. It's the maximum and the minimum battery cell voltage. So from this that equation, we can take the derivative. So derivative with respect to time and for a fixed interval for the monitoring purpose. So in the normal condition, this value always should be 0. But when the battery internal short circuit occurs, the delta Vmax would the derivative would the delta Vmax would continuously increase, and if the derivative falls to positive. So while we monitoring in online, so while monitoring continuously, we will be able to find out when it falls to the positive range, then we can say that the battery internal short circuit is happening. So thus we will be able to find to identify that the battery internal short circuit happens, and if it is continuous, the thermal runaway can propagate to the other battery near to that, so it entirely causes an explosion. So this method is able to find out the battery internal short circuit. So the next one is online impedance method. So in addition to the risk of the cell, output cells are integrated to a pack in the EV for a long capacity and higher voltage. Such integration will lead to a poor inconsistency. So as a result, a slight overcharge and over discharge will occur in the cell, which increases the risk of thermal runaway. So here you can see during the charging, during the charging process, the one with highest state of charge will be overcharged. So here you can see it is charging from this direction from C to B to A. So the one with the highest state of charge will be overcharged, and similarly while discharging, the one with the lowest state of charge will over discharge. Due to this process, there can be a formation of bubbles in the battery because of the overcharging to a certain extent. It will accumulate the bulging, which has to formation of the gases and flame. It eventually propagates to thermal runaway. That is, it propagates to the nearest batteries and gates. So, in order to identify this, during the whole overcharge process, the gap between the positive and the negative electrode is filled with the bubbles, and then the distance between the electrode is elongated as shown in the figure. So here you can see when the bubbles happens, the distance between the electrodes become increases, and so when overcharging, the bubble starts and the bulging happens and the thermal runaway. So in this process, you can see that when the in this next slide, it explains that when the overcharge happens, slope of the dynamic impedance turns positive. That is this graph. Okay. So when this overcharge, the dynamic impedance increases, it's because because of two laws. That is, during overcharging, the conductivity of the electrode is reduced by the bubble, and the distance between the electrode is elongated. So using this equation, we can able to see that the distance is increases, and resistivity also increases. So our entire resistance is increasing. Here you can see the resistivity increases with the temperature. The temperature increases, resistivity also increases. So collectively, our entire resistance also increases. And according to the parallel plate capacitor equation, the capacitance decreases as the distance between the electrode increases. Eventually, as we know that the reactance increases. So collectively, our impedance, dynamic impedance increases, and this will cause a surge in the impedance, and that is what's shown in this figure. So as the bulges and bubbles and bulges happens, the electrode become the distance between the electrode become increases, the slope increases, the value of the impedance increases. So in this point, in this instant, we'll be able to find that the early detection of the thermal runaway by the online impedance measuring device can measure the impedance increment in the early stage. That is, when this starts to increase, we will be able to find this slope turns from negative to positive. So in that stage, we can able to predict the thermal runaway. So by cutting off the charging of the battery, when the dynamic impedance slope turns positive, and this provide overcharge warning and early thermal runaway prediction and enhances the battery safety. So the conclusion is, it is evident that the ongoing research and development in the battery safety or addressing challenges posed by the thermal runaway. The future studies may explore deeper into refining the detection methods, improving predictive tools, and addressing emerging challenges in the quest for safer and more sustainable energy solutions. So the road ahead holds promise for further advancement in battery safety and realization of a cleaner and safer future transport. So these are the references. And that's it. Thank you.
Okay, thank you, Dr. Vishnu. And then we open the floor for the Q&A. If there are any questions. Yeah, they have a question here. Okay.
Dr. Vishnu, good day. I would like to ask about the battery explosion, right? So as we know, we need to have a long time charging for a EV, right? So maybe I will charge the car at night and I go to sleep and I wish for the full charge for the next day. So how about if there is a current drop at the night and then the current from the say the pencawang?
No, I cannot understand. Maybe in English.
The transformer suddenly bring back the power. So it will cause battery explosion or not? Because as I know, when the current came back from the current drop, it's very high power.
So in the overnight charging, the current decreases. So what you said? Can you tell? Can you say the question again?
Oh, my question is, will the battery being overcharged if the power grid drop suddenly and then tick back suddenly?
So the question is that when the overcharges happens, the power drops, then the power goes high. So, so your question is how that happens, or what should be how to identify it?
Yeah.
Sorry, the student not clear. You should let us know.
Because I didn't get the question actually. I'm sorry. Could you know?
The power drop. Maybe they're not clear. But it's okay. All right. I think we can. They have another question. Maybe simple question. Okay, simple questions. Hopefully last and the simple questions.
Hello, Dr. Vishnu. First of all, I would like to thank you. The slide are very precise and clear. But I have one question for you. My question is there an alternative way for the battery of lithium ion used beside that? Because what I see on the slide is many is possibility for the accident. But my question is there any alternative material that can use beside of lithium ion?
So, is there any alternative
yes
to find except the lithium ion batteries or other? Or you're saying that is there any alternative method for identifying the explosion of lithium ion batteries, right? Is that your question?
I'm sorry, Dr. Vishnu. Can you recall that again? Because I cannot clearly understand because of a delay of the internet connection.
Okay. Is there your question is that is there any other method to find out the explosion?
Material. I think
any other material can replace the lithium ion.
Yes.
Replace the lithium ion or
If we drag time, we can cut us for the sini. It's okay. It's okay.
It's okay, Dr. Vishnu. Maybe not clear. Okay, we now
add an answer for that question if you don't mind.
Okay, can you please, Dr. Shea? Okay. Come, Dr. Shah, I have the answer for you.
So actually there are, other than lithium ion material, there are plenty of other materials in progress and developing. In the most recent technology for electric vehicle is the solid state batteries. So there are plenty of researchers going on in solid state batteries, and they are trying to find the material from the sea sand and the salt. Actually, these are the very recent developments in battery technology for automotive engineering.
Okay, alright. So they are on research lagi lah.
They're still under research, Dr. Shah. It's not
Yeah, no,
confirmed
actually,
yet.
solid state batteries will be in the market soon.
Oh,
Solid
the
state
market
batteries
soon.
are expected to be in the market soon. They are very lightweight and more efficient. Yeah.
Okay, that's good.
Thank you, Dr.
Thank you,
Sheikh.
Dr. Shah. Okay, I think we know. Okay. Okay, I think we end up these sessions. Maybe Panzala will continue.
Okay, thank you for all presenter, Dr. Sheikh Muhammad Sultan, Ahmad Azlan, and the last one is the Vishnu Arjis for it's interesting topic for your sharing. Okay, I think that's all for our session. Thank you all of you for your presentation. Is it possible? Oh, okay. Can we take for group photo?
Group photo. Come together. We have group photo.
Group photo.
Boss, come here. Come with the students. Can you please open the camera all? Ma'am, come students with us. Dr. Azlan, my colleagues from where Dr. Azlan, where are you? Are you there still? Okay, boleh nampak dah semua. Come, dekat.
Okay.
So, okay, alright. Okay, that's good.
Okay, boleh?
Okay, boleh. Semua dah? Belakang? Dah?
Okay, saya ke depan.
Okay, depan sikit. Okay. Alright.
Okay.
Okay. Alright.
Okay. 1,
2. Alright.
Okay.
Another one maybe. Is it okay?
One more. Okay, one more photo. Okay. I change the layout first.
Okay. Alright.
Okay. 1, 2, 3. Smile.
Alright.
Okay.
Alright.
Okay, thank you.
Thank you very much.
Okay.
Okay, I'll see you again. Alright, thank you, Dr. Shea, for your help. Thank you very much. Thank you, Dr. Azlan and Dr. Vishnu. Alright, I will see you again soon for the next maybe conference. Alright, thank you very much.
Okay.
Alright, Assalamualaikum and good afternoon. Good evening.
Waalaikumsalam warahmatullahi wabarakatuh.